Welcome to the mathematics class, students. Let us discuss the topic vectors session 1. And the aim of this session is the introduction of the vectors and their characteristics. Also, we'll discuss the types of vectors, that is kinds of vectors, and then we discuss the rectangular resolution of the vectors, that is how does they represented in the rectangular Cartesian system. These are the three topics that we are going to discuss in this session. Here we go with the definition of a scalar and vector quantities. This discussion starts with the physical quantities which are introduced. Whenever we discuss about the physical quantities, there are various quantities like temperature is one physical quantity, distance is another physical quantity, speed is another physical quantity, and displacement is also a physical quantity, and the weight, and then velocity, and then speed, and mass, and acceleration. If we proceed like this, we'll have n number of physical quantities defined in this world. We bother about the units of these physical quantities, but rather if you look at the view of these physical quantities which possess the magnitude, which possess the direction. So let us discuss what do you mean by magnitude. The content kept in the quantity is magnitude. Temperature so many degrees, distance so many meters, kilometers, etc. Speed certain units per displacement, it is a movement in a particular direction. Weight acting towards the weight mass of the earth. Velocity the rate at which the change of displacement is done. Speed and mass, acceleration. All these quantities will be quantified, so they are having magnitude with them. There is magnitude for these quantities. Now the question arises with the direction. Do the temperature acts in a particular direction? No. Do the distance act in a particular direction? No. Does the speed acts? No. Whereas the displacement, yes. Because displacement is the change in the position of the body in a particular direction. Weight, yes, it acts towards downwards. Velocity, yes, as it is defined from the displacement. Speed, again no. And the mass, also no, it is the content of the object. And acceleration, yes, because it is defined from the velocity. So the quantity where you will find the yes, all those are said to be the vectors. And the quantities where you can find no, all those quantities are scalars. Like the scalars are nothing but the real numbers. The properties of real numbers holds good with the scalars in a good synchronizing manner. So finally what we decide, the physical quantities with magnitude only, they are said to be the scalars, and the physical quantities not only with magnitude but also direction, that is direction plus magnitude, is said to be the vectors. Hence we define the vectors and scalars as the scalars, the physical quantities with only magnitude, whereas the vectors, the physical quantities with direction as well as magnitude. So we define the scalars and vectors as physical quantities with number 1 only magnitude, that is content, they are called as scalars. And the physical quantities not only magnitude but also direction, that is both magnitude and direction, then they are said to be the vectors. So that is what physical quantities are defined. Let us observe an animation related to this content in this way. Observe that this is a point here from which a body is being traveled in this direction, which is shown by these arrow marks, and it is reached to point B. Now here this yellow arrow shows the shortest possible distance between the stations A and B. This is what is called the displacement. So here the body is shifted its position from A to B, traveling in these directions, but finally it is shifted to here. So this is motion in one particular direction, which you call it as displacement. This is a vector. And here all the scalars are compared to the real numbers. So we compare the scalars or nothing but the real numbers, and we stop the discussion of the scalars. Here it will that we compare the scalars as the real numbers. Now let us have the discussion over the vectors. First of all, we'll begin with the representation of the vectors. How do we represent a vector? Now representation of the vectors. Just now we observed that when there is a point A, from this a body is shifted its position to point B and traveling in a different direction, but this is the shortest possible distance, what you call it as displacement. So displacement is a vector which is denoted by from A to B, this is from A to B, and it is upon bar, this is called line segment AB, has some direction A to B, this is what is called vector AB. If at all the length of AB is taken as some small a, then we can denote AB bar as small a bar. For better understanding, let us observe this animation related to this point A and point B. From A to B, the direction is from A to B, and here the length of AB is taken as the magnitude of the vector and the direction of the line segment is this. Hence, representation of vectors is done by a directed line segment. So, the vectors are represented by what we state here. The vectors are represented by means of a directed line segment. A line segment having a direction. This is how the vectors are represented. Now the point of this one is called initial point, and the one where it is stopping is called terminal point, and direction is from A to B. So this is represented by vector AB bar or A bar. Also, in due course, we represent the vectors in triad form like A1, A2, A3, where A1, A2, A3 are the components. These are components. This discussion will make at the ending of the theory part that why a vector has been represented in a triad. This is what is ordered triad. This is what is called ordered triad. So where A1, A2, A3 are components, and what is the meaning of defining a vector as a triad and its reflection, we'll see at the end of this topic.